Good morning, dear students. Today,
Good morning, sir.
Lesson.
Good morning, sir.
Good morning, sir.
Good morning.
App
Students, we are seeing the solution lesson. Okay. In solution lesson, today we are going to discuss about the solubility in solubility, the effect of temperature and pressure on solubility. This is a topic which we are going to see today. Today we are going to see the effect of temperature on solubility. Effect of temperature on solubility. As you know very well, what is called solubility? The maximum amount of solute that can be dissolved in a specific amount of solvent. For example, solubility is nothing but if you take a NaCl in 100 ml, that is a specific amount of solute, 100 ml, only 36 gram will dissolve. So what is the solubility of NaCl? They ask, that is a 36 gram. Why we are saying that 36 gram is a solubility of NaCl? Because in a specific amount of solvent, that is 100 ml of solvent, only 36 gram of NaCl will completely dissolve. What happens, sir, when I add some more amount of NaCl? If you add some more amount of NaCl there, it will be precipitated. If you add less than that, little more solid is needed. So exactly 36 gram of NaCl will dissolve in a 100 ml of water. That is the solubility of NaCl. That's already we have seen. Now we are going to see how the temperature affects the solubility. As you know very well, what is the solution? Solution is made up of solute and a solvent. Solution is nothing but a solution. Solution is nothing but a solute plus solvent. Solute plus solvent. Okay. So here in the solution lesson, we are dealing with the solvent is a water, liquid in state. Solvent is a liquid in state. The solute may be a solid or gaseous form. So there are two types of systems available here. When a solid solute that is a solid in nature in a solvent. in a solvent. Solvent is a liquid state. This is the system which we are going to see. Solute in a solvent, that is solute, the solid solute in a liquid solvent. This is system number 1 that we are going to see. System number 1, that is a solid solute in a liquid solvent. What happens when the temperature increases? Okay. As you know very well, when a temperature increases, the statement is given that temperature increases, solubility also increases in this type of system. Solubility, yes, increases. When the temperature increases, solubility increases. How solubility increases from the system? Okay. That we are going to see. Whenever temperature increases, temperature T increases, there will be increases in average kinetic energy. Average kinetic energy. Average kinetic energy also will increase. What happens when average kinetic energy increases? Average kinetic energy increases. If average kinetic energy of solute and solvent increases, the force of attraction between the, if you consider this is a solvent molecules are there, they are binding like this, the force of attraction between the solvent molecule, as if this is a solvent molecule. Likewise, if you imagine this is a solute particle, solute, there will be some force of attraction exists. When the temperature increases, these force of attractions are the bond between the molecules are broken. As a result, they can easily mix together. The solubility increases. As a solute and solvent are mixing with each other, it will be more when a temperature increases. How temperature improves the solubility? This is called solubility. Dissolved form. Where how the temperature influences, when the temperature increases, average kinetic energy also increases. When the average kinetic energy increases, the force of attraction between the solvent and solute molecules are very, very less. Or the bond between the intermolecular forces are very less, or break the intermolecular forces. As a result, they can easily miscible with each other. Thus, the solubility increases. In such a way, we are come to the conclusion that when temperature increases, solubility also increases. This is the first point. Okay. So when this is a beaker like this is a solvent, liquid solvent is there. So liquid solvent is there. When you add a solid solute, this is a solid solute particle is added. What happened? Solid solute particle is added. It will dissolve. First, if you add a solid particle to the solvent, like you take a sugar into the water, but it will be getting dissolved. Okay, this process is called a dissolution. This process is called a dissolution. Dissolution. What is called dissolution is nothing but when a solid solute dissolving into the liquid solvent is called a dissolution. When a solid solute dissolve in a liquid solvent is called a dissolution. If you add a more number of solute, again and again, what will happen? It will get precipitated. You take example, you take a tumbler of water, you pour a spoon of sugar into it, it will be dissolving. Upon adding more and more amount of sugar, you will get a sugar particle at the bottom of the tumbler. Likewise, when you add a more amount of solute, then there will be you will get a precipitation. Returns back to the solid state. Again, you will see that a solid solute. This process is called a recrystallization. Recrystallization. Okay, dissolution and recrystallization is clear. Dissolution means when you add a solid solute into the liquid solvent, they start dissolving. You will not find that if there is any solid particle, you cannot see at all. When you add a sugar into the water, first you cannot see the sugar because the sugar getting dissolved into the water. That is called dissolution. Upon adding more amount of sugar into the water, you will have and finally you can see that the sugar particle at the bottom of the tumbler, that is called a recrystallization. Okay. So what they are coming to say, there is a equilibrium exists. There is a equilibrium exists between solid solute, that is solute in a solid condition. Equilibrium exists. Solute in a dissolved state. Solute in a dissolved state. S for solid, you make solid. Solute solid, then solute dissolved. Solute dissolved. There is a equilibrium exists between the solid solute and dissolved solute. Okay. So the process, now I am explaining the dissolution. When a solid solute becomes dissolved, that process is called a dissolution. That is a forward direction, that is dissolution. In a backward direction, that is a recrystallization. Backward direction, the program is called a recrystallization. Okay, recrystallization. When the solute start dissolving, the process is called dissolution. When the solute get back to the solid state, that's reverse direction, that is called the recrystallization. Now it is clear what is called dissolution, what is called recrystallization. Okay, so there is a equilibrium exists between the solid solute and the dissolved solute. Let's say, okay, there is a equilibrium exists between the solid solute and the dissolved solute. Whenever equilibrium arises, that principle you have to recall, that is Lee-Short-Layer principle. Lee-Short-Layer's principle. What he is saying? Simple thing. Already we have studied in the equilibrium lesson last week. Equilibrium lesson we have discussed it. What is called Lee-Short-Layer principle? Very, very important principle. Very often you have to come across the principle. Lee-Short-Layer principle. Any disturbance given to the equilibrium, this is called equilibrium. Any disturbance given to the equilibrium tends to nullify the disturbance. Equilibrium itself tends to nullify the disturbance. If any disturbance, how the disturbance can given to the equilibrium? By the concentration, by the volume, by the temperature. These are the factors which can disturb the equilibrium. If any disturbance is given to the temperature, pressure, concentration, it will nullify the disturbance. This is called Lee-Chatelet principle. According to Lee-Chatelet, it is relevant to the temperature. There are, even if it is a equilibrium reaction, there is two chances are there. One is a endothermic process, another one is a exothermic process. Endothermic process and the exothermic. When during the process heat is absorbed, that is called a endothermic. During the chemical process, when a heat is released, that is called a exothermic process. Endothermic and exothermic. Okay. When a heat is absorbed, that is endothermic process. When a heat is liberated, the exothermic process. Here, Lee-Chatelet is saying this: when a temperature increases, we are discussing about the solubility. What happened to the solubility when a temperature increases? In endothermic process, when a temperature increases, solubility also increases. Solubility also increases. This is the statement. In a equilibrium process, one direction is endo, the opposite direction should be exo. If I consider forward direction is endothermic, that means when a heat is absorbed during the process, that is endothermic. Then the backward reaction should be opposite to that. Okay, what is that? Exothermic. Heat is released. during the exothermic process, what happened? Exothermic process, when a temperature increases, solubility decreases. Solubility decreases. Why? Because the endothermic forward direction is favored. Exothermic, during the exothermic, temperature increases, then the backward reaction favored, the solubility decreases. This is given by deep shock layer principle. By using this, there are few salts are taken, like what are the salt is taken, the experiment done, solubility of NaCl, ammonium nitrate, NH4, NO3 ammonium nitrate, and then calcium chloride, and then ceric sulfate, nanohydrate, ceric sulfate, and nanohydrate. Nano, 9 times of water. There is an experiment done. That is the effect of temperature is analyzed by using these solid particle. Then you are getting the result. You have a graph for that we are going to see now. Temperature versus solubility. What happens when a temperature increases to that? See, if we look at the graph, see, that is a solubility versus temperature. Graph is given, the x-axis we have taken a temperature, in y-axis you have solubility, the solvent is water, that is 10 gram of water, 100 gram of water is taken. If you see the solubility of each and everything, ceric sulfate, first from the graph what we are inferring that the solubility of sodium chloride does not vary appreciable as the maximum solubility is achieved at normal temperature. See, at normal temperature, there is no change in the solubility of NaCl, sodium chloride. In fact, there is a little bit changes is there. If you look at this, there is a little bit minute variation is there. That's why there is a 10% increases in solubility. 10% increases. If we take dissolution process of ammonium nitrate, dissolution process of ammonium nitrate is a endothermic in nature. As I said earlier, in endothermic process, what happened to the solubility? In the endothermic process, solubility increases with the increasing temperature. If you see ammonium nitrate, the graph is going on. When the temperature increases, solubility also going on increases. Solubility increases. So, since it is an endothermic process, solubility increases with the increasing temperature. In the case of ceric sulfate, this is a exothermic. What happened to the exothermic? The exothermic process, solubility decreases with the increasing temperature. Solubility decreases with the increasing temperature. That's the ceric sulfate. The graph is going like this. See, the graph is going down. Ceric sulfate. Then, even though the dissolution of calcium chloride is a exothermic. It is a exothermic. Then exothermic process, what is that? Solubility. Solubility should be decreases with increase in temperature, whereas here solubility increases moderately with increase in temperature. This is controversial to that. Why? Because we cannot determine the factor of solubility only with the XO and NO. There is another factor that is called entropy. In the thermodynamics, we are going to study in the forthcoming weeks what is called entropy. Entropy also play a vital role to determine the solubility. Okay. Then let us move on to the next type of second system, that is what is the system is there? Gaseous solute. Solute in a gaseous state. Solute in a gaseous state in a liquid solid. In a liquid solid. So far we have discussed a solid solute in a liquid solid. That is the first step. Now we are going to discuss gaseous solute in a liquid solid. What happens to this when a increase in temperature? Here the solute is a gas. If a solute is a gaseous particle, then when the temperature increases during this system, when the temperature increases, there is decreases in the solubility. Solubility will decreases. How, sir? So let me explain this. See, when the temperature increases, as I said earlier, what will increase? Temperature increases. Average kinetic energy also increases. Average kinetic energy. Kinetic energy also increases. If the average kinetic energy also increases, that means the bond between the solute and solvent, bond between the solute and solvent particles, solute and solvent particle. Solute and solvent particle will be very big because solute in a gas is, for example, if you take the diagram, solute in a, see there, this is solvent. Solute is a when they dissolve it will be like this, dissolving into the. What happens when a temperature increases? If I raise the temperature here, temperature increases. The bond, the intermolecular force of attraction will be the liquid particle and the gaseous particle will be very big. Then the gases will expel easily. As a result, you will have a very less number of gaseous particles inside the solvent. Very less number of gaseous particles, only few gaseous particles will be, whereas more particles will away from that solvent. What it means? It means that when a solute is in gaseous state, when the temperature increases, the gaseous particle from the solvent liquid will come away. If it goes away, it says that the solubility decreases. Then the solubility decreases. Once again, I am repeating. If a solute is a gaseous state, then it is mixed with water, there will be dissolving. Few amount of gaseous particle will dissolve into the solvent molecule. When the temperature rises, what happens? The gas will go away, gaseous particle will go away. Why? Because, as I said earlier, the average kinetic energy increases. when an average kinetic energy increases, there will be the binding forces of attraction between the gaseous solute and the liquid solvent will be very less. As a result, solubility. Okay, this can be expanded with some activity that we are going to see. See, take a soda bottle. You assume that it is a soda bottle. There will be a dissolved gas. Already you know very well in a soda bottle, dissolved carbon dioxide is there. That is a carbonic acid, water. Okay. What is that? Dissolved carbon dioxide gas will be there in soda bottle. If you cover the open by a balloon, okay. When a soda bottle is open and cover the head by the balloon will be inflated. Why? When the gaseous carbon dioxide will go away, they will inflate the balloon. Okay. The same experiment done on hot water. You keep that soda bottle. Same experiment done on. Cover the balloon. The same activity, we do it in a hot water. Or otherwise we heat it. By heating, temperature increases only. I am telling that if we do it in a hot water. What happens? This is an ordinary thing. Here also carbon dioxide will go away. Here also that carbon dioxide will only go away. But if you cover the mouth of the soda bottle by with the help of the balloon will be getting inflated in both cases. That is not doubt at all. In both cases, the balloon will inflate. But there is a variation in that here the inflating ratio will be greater. See, the balloon inflating rate will be greater. Why is that? What happened? This is the same soda bottle, same amount of carbon dioxide is there. There is no change at all. The same bottle, when you open, the carbon dioxide is going out. When going out, it will inflate the balloon. The size will be, you observe the size. If you take the same size of soda bottle, when it's open, it's kept under the hot water. Under the hot water, the rate of inflating will be more. Why? Because what is the difference between the here? Temperature is increases. While temperature increases, what happens? The gaseous particle, that is a dissolved carbon dioxide inside the soda bottle will go away. Completely go away with a very fast rate. That's it. The activity is given to you. You can go through the activity. Open the soda bottle and put the balloon over. The balloon will inflate with this carbon dioxide from the soda. Carry out the same experiment by placing soda bottle in the container of hot water. The same experiment, same bottle, same carbon dioxide will be evolving. Both cases, carbon dioxide, both are inflating the balloon, but the difference is that the balloon will be very small in size, where here the balloon will be very big, larger in size. Why? What happened? Because what's the difference between the two experiments? Is the temperature increases. As a reason of temperature increases, you are getting that inflation rate is more. It's say state or its source state. When the temperature increases, solubility decreases. When the temperature increases, solubility decreases. In what system? Solute solute in a gaseous state, solute in a liquid solid. Solute in a liquid solid. So far we are discussing the effect of temperature and solubility. The effect of temperature and solubility says that there are two systems are there. Solute in a solid state in a liquid solvent. Another one system, solute, gaseous solute in a liquid solvent. There we have discussed detail about that. Then the second system, when the temperature increases, what happens to that solubility? When its temperature increases, if a solute in a gaseous state definitely decreases the solubility. Now let us move on to the effect of pressure. The effect of pressure. So what we are going to do now? The effect of pressure on solubility. On solubility. Effect of pressure on solubility. Here also the two systems are there. One are the system number one, that is solute. Solute in a solid solute in a liquid solvent. So solid solute in liquid. What happens? The effect of pressure. So in the system, there is no effect of pressure. No effect of pressure. No effect of pressure in this system. And a solute and solvent are liquid and a solid and liquid state, there is no effect of pressure because there is no compressible significant pressure. There is no significant effect in solubility of solid and liquid as they are not compressible. As they are not compressible. Who? The solute and solvent. Because they are in a solid and liquid state. Solid and liquids are not easily compressible. Thus, there is no effect of pressure. Okay, it's clear. There is no effect of pressure in the system of solid solute and a liquid solid. Then what is the second system? System number two. That is solute in a gaseous state. Solute in a gaseous state. The gaseous solute in a liquid solvent. So there must be a effect of pressure. There must be a effect of pressure. There must be a effect of pressure. What type of effect will be there? That we are, because gas is there, solid and liquid, they are not easily compressible, so there is no effect of pressure. Here the effect of pressure will be there. That is pressure increases, solubility also increases. Pressure increases and solubility also increases. Pressure increases and solubility also increases. Because the solute gaseous state, there is a equilibrium arises between the solute in a gaseous state and the gas which is a dissolved state, gas in a solution. Gas in a solution. So there is an equilibrium exists between these. What is the equilibrium? Equilibrium exists mean you have to say that D charge will come here. D charge always come here. whenever the equilibrium arises. Lead short layer. What is lead short layer? Lead short layer. Lead short layer. What is lead short layer saying this? Lead short layer. The lead, according to lead short layer principle, whenever pressure increases, in order to nullify the disturbance, the reaction favors the direction to reduce the pressure. Whenever pressure increases, lead short is saying that pressure increases, the equilibrium shifts towards nullify the pressure. So the equilibrium shifts towards the forward direction. Forward direction. What is the forward direction here? In solution. So more amount of this is a forward direction. Forward direction, what happening? In the forward direction, you are getting the dissolution. Okay. So solute particle will dissolve more. That's it. So the finally we can conclude that pressure increases, solubility increases in dash, where that is a gaseous solute, in a liquid solid. For the diagrammatic representation, we can have diagrammatic representation for this. See, under the normal condition, the blue in color is there, no? It is a sky blue color, that is solution, liquid. The dotted particles are gaseous particle. These dotted particles are gaseous. Liquid and gas. Okay. Under the normal condition, what happens? There are few gaseous particles inside the water. But whereas the more gas molecule at a soluble at high pressure, this is a normal condition at a high pressure. Pressure is introduced. What happens? See, the variation between there is equilibrium exists in both cases. Here, more number of gaseous particles are there. Here, more number of gaseous particles without dissolving. But while the pressure increases, you can look at the diagram. While the pressure increases, number of gaseous particles into the solvent is more. More number of gaseous particles are there. So more number of gaseous molecules are there into that under the high pressure. It expands or it says that when the pressure increases, because what happened to this? If you look at the two diagrams, the more number of gaseous particle is there, it shows that the number of gaseous particle is dissolved in more, that is solubility increases. Thus, pressure increases, solubility increases. This is the result. Pressure increases, solubility increases. That's all. Today, so far we have discussed the effect of temperature and pressure. Okay, let us recall and revise what we have seen. There is solution lesson. The lesson is solution. In the solution lesson, we are dealing with topic solubility. What is called solubility? The maximum amount of solute present in a specific amount of solvent. In that also, we are dealing with today. We are dealing with the effect of temperature on solubility. So solution is nothing but a solute and solvent. The combination of solute and solvent is called a solution. There are two systems are there. There are many systems are there. Here we are going to deal with the two systems. When a solid solute in a liquid solvent. What happens when a temperature increases? So effect of temperature means if the temperature increases, is there any changes in a solubility? Yes, of course, as you know very well, when a temperature increases, solubility also increases. In general, we are saying how the solubility increases in the system. We need to explain. Here, solute is solid, solvent is a liquid state. When a temperature increases, average kinetic energies of solute and solvent increases. As a result, you are getting that the force of attraction, the bonding between the solute molecule and solvent molecule, the molecules of solute is make free and solvent also make free. So they combine very easily. As a result, they will mingle with each other easily. As a result, you are getting the temperature increases, solubility increases. When you add a small amount of solute into the solvent, that process is called dissolution. I explained that with the use of sugar and water. If you add a more solid particle, then you start the precipitate. It's called recrystallization. So when you dissolving, there is an equilibrium exists between the solid solute and dissolved solute. When a solid solute dissolving, it is called dissolution. The same, the solute is forming that solute solid particle, that is recrystallization. So whenever equilibrium exists, you may find the Xi-Chemistry-Solubility principle. Xi-Chemistry-Solubility principle. Okay, the Xi-Chemistry saying that what is the Xi-Chemistry always come to that the XO and the NO differences is giving Xi-Chemistry. The XO and the NO. The difference generally we are saying the increase in temperature. But here in endothermic process, solubility increases, whereas in the exothermic process, solubility decreases. Then the different analyzation graph we have seen with the different solvent that already we have discussed. After that, the second system we have seen that solute in a gaseous and a liquid solvent. There you are getting a decrease in temperature. Solubility decreases with a increase in temperature. With the soda bottle experiment we have seen. Then effect of pressure we have discussed. Effect of pressure on solubility. The system number one, solute, solid, and liquid solvent, there is no effect of pressure. But whereas solute is a gaseous particle, then there must be an effect. Pressure increases, solubility also increases. Okay. According to Xi-Chemistry, whenever pressure increases, the equilibrium tend to nullify the disturbance. That nullify the disturbance by favor where the pressure is reduced. As a result, we say pressure increases, solubility increases. For example, we have seen that under the normal condition, there are also dissolving is taking place, but a very less number of gaseous particles inside the water. That is liquid. But under the high pressure, if you look for that, the number of gaseous particles above the liquid is very less, but inside the liquid is more. That means more solid. So finally, we can conclude that pressure increases, solubility increases. That's all, dear students. If you have doubt, we can explain.
Good morning, sir.
Good morning, sir.
Morning, dear
Sir.
students. Today we have
Good morning.
the effect of temperature and pressure on solubility. Do you have any doubt regarding this?
No doubt.
No doubt,
sir.
sir.
Yeah. Let me ask some question towards you.
Yes, sir. Yes, sir.
What happens when the temperature increases to the solubility where the solute is a solid and a liquid solid?
So increase the solubility.
Increases.
Okay, good. If it is exothermic process, what happens to the solvent?
Decreases.
Decreases the solubility decreases.
What about the effect of pressure and salinity?
Increases, sir.
What happens when the effect of pressure when a
Increases.
solid solute and liquid solvent?
Decreases.
Decreases solubility.
No, this is the question proper answer. Question is solid, liquid solvent. What about the pressure effect?
No effect.
Good, that is right.
Effect is no.
There is no effect. Why? Why there is no pressure effect?
There is
Solid and solvent.
The solid and liquid are not easily compressible. That's why there is no effect of pressure.
no effect.
Okay, dear students. Tomorrow we will discuss the chemistry stuff. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.